Okay, hey, let's talk about vectors and scalars. So let's first start by talking about a scalar. What is a scalar? Something like mass or how much I have of something is a scalar, right? It's a single number. It's a single number which describes something like my mass is X. Right? It is a single number. Now, there are other things in physics which are called vectors, right? They're going to be categorized as with a magnitude and a direction. Okay? So, that's like saying I'm going 60 miles an hour on the highway and I'm going east, which is different than going 60 miles an hour on the highway and going west or north or south, right? So the magnitude is how fast they're going and the direction is the direction of which they're going in. And so in physics, what we're going to do is, to be very precise, we're going to define a couple of things. So the magnitude is you can think of this as like how much. And we could use north, east, south, and west for direction, but instead we're going to use the angle from the x coordinate. So we'll start in 2D, right? It can get to 3D, right? But we have the x and the y. Okay, so the direction would be, if this is where I am, if I'm right here, which direction am I going in? Right, so let's say I'm going that direction, right? Then I'm gonna point an arrow. Now, how long should the arrow be? Well, it should be exactly the size of how much. So that if I had some scale here, right, and some scale here, you know, and then I were to look at a legend, like on a map, this distance here, from the end to the start, would be how much? It would be how much. Okay, cool. So the angle, or the direction, we're going to define as starting from the x-axis going towards the y-axis. So this is theta, right? So when I say like the direction, I'm talking about theta, right? So there are 4 quadrants. 0 to 90 degrees is quadrant 1. Quadrant 2 is from 90 degrees to 180 degrees. Quadrant 3 is over here where we go from 0 all the way greater than 180 but less than 270. And quadrant 4 I get a choice. I can either make this angle negative, right, that it's pointing down like that, or I could go all the way around from 270 to 360. Either one works. Cool beans? Okay. Let's now just focus in quadrant 1 for a moment. All right, so focusing in quadrant 1, if we have this vector here, we'll call this A. Now we put a little like line on the top of A to indicate, yo, I'm a vector, right? For like a scalar, we wouldn't. We would just write like the mass is just m, right? But if I have some vector A, I gotta put a little like hat on him, this fancy hat, which is just saying like, yo, you're a vector. You have both magnitude and direction, right? You're special. Okay, so I could say my vector A is equal to a magnitude A, right? It's magnitude. Notice there's no hat on the magnitude, right? At theta degrees, right? So there I'm giving a magnitude and a direction. That's one way to write a vector. Now there's another way. And we're going to get into this as you were watching the IVV with the projectile motion. You kind of noticed that the x direction and the y direction were independent from one another. So why not break my vector down into a piece that goes in the x and a piece that goes in the y? So to do that, we drop a small triangle here, boop, 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 right? And we notice that this here is a right triangle. And once we know it's a right triangle, it's like happy trig time, SOHCAHTOA, right? So SOHCAHTOA, right? So this is the thing that you might have learned when you first learned trig. You know that if I have a right angle here, and this is my angle phi, if I have the opposite, the hypotenuse, and the adjacent, the SO is going to be the sine of phi is equal to the opposite over hypotenuse, right? The ka part, right? You're going to have it's going to be the cosine of phi is equal to the adjacent over the hypotenuse. And then, of course, there's the TOA part, which is that the tangent of phi equals opposite over adjacent. Right? So we know these kinds of things, and we also know that there's something special about how A, O, and H are related. We know just standard Pythagorean Theorem. Right? A squared plus O squared equals H squared. Okay. So knowing these relationships, and knowing that this is a right triangle, I can break down A into a piece that's going in the x direction and a piece that's going in the y direction. So let's see what that looks like. I have the part that's going in the x direction, I'll call AX. We'll call this the component in x direction. And then I'm going to have a component in the y direction, AY. Okay, so, well, I can immediately see that if I know A and I know theta, I can find what AX and AY is, right? Because I know, so, the sine of theta equals AY, the opposite over. Now, we know this distance is the magnitude, so over A. And we know that, again, the ka term, that the cosine of theta is going to be equal to now the adjacent, which is AX, over the hypotenuse, which is A. So this tells me that AY, just doing some cross multiplying, is A sine theta, and AX is equal to A cosine theta. So it's really interesting here. I could write my vector as A at theta degrees, or I could write my vector as the component in the x direction times what it means to be in the x direction, plus the component in the y direction, plus what it means to be in the y direction. Holy cow, it's a whole new kind of hat! That's crazy. We got an I hat and a J hat. What the crap are those? All right, let's take a look. I hat. First off, anything with that kind of hat, the magnitude is 1. It's a vector, right? So if I write its magnitude, right, we can write a magnitude of a vector as, you can write it like this. 2 lines, this is equal to A, which is the magnitude. Right? So if I have I hat, the magnitude is going to be 1. It just is. It's a property of anything with that kind of hat on it. It's telling me that it is 1 step in the x direction. So I'm going to go 1 I hat means 1 step in the x direction. So I go 1 step. Now if I go j hat, so 1 j hat means 1 step in the y direction. I would jump, but I'm afraid of what it will do to the floor. Right? So basically, if I want to know what A is, I take how many steps are in the I hat in the x direction times the number of steps in the x direction, plus how many steps are in the y direction times what it means to be in the y direction. So it's like I go boopity 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 boop in the x direction, and then boopity 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 boop in the y direction. Cool beans?